Plastic pollution has a negative impact on multiple aspects of our ecosystem, threatening ocean health, food safety and quality, human health, coastal tourism, and contributing to climate change. The emphasis of our project is on understanding the current predicament we face in terms of the effects of single-use plastics. Plastics are seen to accumulate within the bodies of our scaled and feathered friends, and in turn, us. Not much has been studied in terms of actual human accumulation. However, in lab mice, it has been shown to accumulate in the liver, kidneys, and intestines. The amount of bioaccumulated microplastics is ever increasing, as is the production of harmful toxins and byproducts, including those in both the creation process as well as the breakdown and leaching within current waste management practices. For many years, we've been playing a kind of damage control, finding means to put out of sight, and thereby out of mind, the multitude of poisons and toxins that refuse to simply just go away. With ever-increasing awareness and research being done to prevent this damage, the drive to address these issues is necessary to change how people as a society view single-use plastics. Single-use plastics can be traced throughout all human interactions, from industry to all manner of health. To find an area where we could affect real change, we focused on the lab space. To highlight the need for change, while only 0.1% of the entire population is involved in research, and a fraction of those individuals are involved in the physical lab space, researchers account for 2% of all plastic waste, according to a study published in Nature magazine.
At the laboratory level of plastic use, evaluating these 5 stakeholders is our imperative. As the most removed stakeholder, government foundations fund scientific research through grants, showing that they have the ability to place a recycling aspect in the eligibility section of grants offered to principal investigators. The university itself strives to provide top-notch academic teaching as well as innovation. However, it is highly concerned with its image and public perception. A possible improvement to the recycling operations could bring good press along with it. Department heads, with their extensive connections and networking, could prove valuable in changing and implementing new recycling measures while ensuring that the department's image and efficiency stay intact. The primary investigators are the main point of decision for each independent laboratory. They compose all standard operating procedures that are carried out in their lab, as well as grant proposals that are submitted under the laboratory's name. Lastly, serving as the boots on the ground, lab technicians have direct impact on how precisely new operating procedures are followed task to task. However, technicians usually have little to no say in operating procedures that are put in place.
3 things need to be accomplished. Right now, sustainability suffers from a lack of commitment, seemingly just another buzzword similar to being green. Transitioning this idea away from the margin to being a supporting pillar is vital to our accelerating globalized world. Our academics are our teachers, our guides, our role models. They are those who spring to mind in terms of who knows best. If all of them can't follow their own advice, how could most others be expected to heed them?
In order for lab plastics to be suitable for recycling, potentially dangerous chemicals and biologics must be neutralized and removed. To do this, the lab plastics recycling coordinator recommends either a triple rinse and bleach or a standard autoclave. Either option is more than capable of removing even the toughest biologics, but the rinse and bleach procedure should be used for chemical hazards.
After thoroughly analyzing both large-scale and localized aspects of the single-use plastics problem, our team has devised a 3-step solution to serve as a foundation for university research laboratories.
Infrastructure-wise, the underlying requirements are already in place. All we need to do is increase awareness and train people to use the recycling program effectively. We propose a training module, much like ones used to train lab safety and HIPAA requirements. This module makes it easier for employees to get informed about the recycling services offered and how to utilize them.
Currently, there is no specified webpage run by the U of M's recycling facilities that tailors to laboratory recycling. This makes it harder and more confusing for individuals interested in learning more to find the right information. We propose that there be a central webpage that makes information easily accessible, including an easy-to-locate request mechanism for labs interested in acquiring a receptacle for their facility. There is currently no legal requirement for university laboratories to recycle in any form. The only real incentive, personal morals. Enter grant money. We propose that university or governmental research grants introduce a new proposal section. Requiring a laboratory recycling mitigation plan in any grant proposal will serve as a criterion for their pursued grant funds. This allows labs to tailor their proposed waste mitigation plan explicitly to existing standard operating procedures. Under this plan, labs can enter our green competition and may the most sustainable labs profit.
For the individual, the 3 steps are simple. Here we catch a glimpse of the underlying complexity, the systems that foster and bolster the associated status, grant money, achievement, social proof, etc. The road to sustainability since the Brundtland Report of 1987 has been paved and waiting. By addressing the sustainability of research-based universities, specifically their roles as leaders in knowledge and innovation, we can assure we are well on our way to a sustainable tomorrow.